Hello guys, today we're going to go over the first half of 1.1, which is pretty much analyzing categorical values, categorical data. Now, we begin right off the bat with going over frequency tables and relative frequency tables. They are similar. The basic difference is that the frequency tables gives you the exact number of the people who have a particular value or are assigned to a particular category, and the relative frequency table pretty much shows you the proportion or percentage of people who fall into that category. Now remember, the proportion is pretty much the number stated in decimal form. Let's say 2 out of 10 people like lollipops, the proportion would be 0.2, and the percentage would be the proportion times 100, or 20%. So you have to be very careful when you read the questions and they ask you for a proportion or a percentage. If they ask you for the proportion and you answer in percentage form, will be wrong. If they ask you for a percentage and you answer in proportion form, it will be wrong. So just keep that in mind. Now let's go over the frequency tables and the relative frequency tables. In the book, we have some sort of survey that was done, and it shows the preferred method of communication: cell phone, Facebook, in person, or text messages. And the tally, or the people who answered or who fall into these categories, the tally. For cell phone, we had 2. For Facebook, we had 1. For in-person, we had 3. Text messages, we had 4. When we add them, I see a total of 4. Now, no, remember, tallies are, let me just go ahead and fix this. Since it's tallies, you just mark them off. 1, 2, 3, 4, 5. But in a frequency table, we're not going to show off all the tallies. So we're going to actually turn the tallies into numbers. So a frequency table would pretty much, all it says is preferred method up here, preferred method. And then here, we just put the frequency. Frequency. Cell phone, 2. Facebook, 1. In person, 3. And text messages, 4. Pretty straightforward. Just count how many people qualify for each category and put the number right there. That's simple. Now, a relative frequency table is similar, but all we have to do is turn these numbers into proportions or percentages. You can use both proportions or percentages in relative frequency, but you do have to state which one you're using so it's clear. Okay, so if I'm going to turn this into relative frequency, again, I have a total of 10 survey responders. 4 plus 3, 7, 8, 9, 10. So I have a total of 10. In order to find the proportion, you're always going to put the number of people who qualify in that category divided by the total number of people. So 2 divided by 10 gives me a proportion of 0.2, or 20%. 1 divided by 10 gives me a proportion of 0.1, or 10%. 3 would be 0.3, or 30%. 4 would be 0.4, or 40%. Now note that there are benefits and pros and cons to using one or the other. Now, the pro of a frequency table is that at least you get an idea of how many people were surveyed. Because again, if someone comes up and says, oh yeah, according to the surveys, 90% of the people think that this is the best math class. Well, no, how many people did you survey? Well, no, only 10. Versus maybe 100, 500, 1,000, 10,000. And the more you survey, the closer you are to what's considered the truth. We'll see in statistics how interesting that is. So again, showing just the percentages or the proportion doesn't tell you how many people were surveyed. So, you have to be a little careful there. And at the same time, showing just the frequency sometimes isn't very helpful. So say for example, 717 people are from one category and 1,213 are from another category and 10,150 are in another category and 2,500 are in another category. When you see numbers like this, it's kind of difficult to visualize proportions. That's where the benefit of the relative frequencies comes in. You kind of are very easily able to see how one category compares to the other without having to put a lot of mental work into it. They gave me these numbers and they say, oh, okay, these are the people that like pizza, these are the people that hate pizza. It's very difficult to visualize these numbers as proportions. So again, the benefit of the relative frequencies is you're able to quickly see how one group compares to the other frequency-wise. The disadvantage is you don't see how many people were surveyed. In frequency, it's the opposite. You see exactly how many people were surveyed, but it's kind of difficult to wrap your head around how the proportions work. If I had to choose just one to use, I would choose a proportions, because you can easily just see the differences. But again, you really need to know how many people were surveyed to get an idea of how trustworthy that information is, or that survey question was. So now to continue, give me 1 second. Now, once I have this information, besides a frequency table and a relative frequency table, how can I display this information? Pretty simple. Bar graphs or pie charts. These are categorical variables, not quantitative. So we're going to use bar graphs or pie charts. Do not use histograms. Again, bar graphs have different bars of different colors. We use that. Histograms, they are all stuck together. We do not use histograms. Okay, histograms are for another data type. Categorical variables, we put them in very nice separate categories. The other way we can, use to display is the pie chart, where each 1% corresponds to 3.6 degrees. Again, if you're using a protractor, if you're going to use a protractor, you do a circle with a compass, and then you have to convert your percentages into degrees, and that's how many degrees each pie part has. Now note, the book says it very clearly, technology will do this easily for you. We're probably going to do this by hand in class because I like to give you guys a hard time, but you're not going to actually ever do this by hand, but we're just going to do it once in case, we ever lose all our computers and all our technology and you have to draw a pie graph for some reason. Although if that happens, you'll probably have bigger problems. But we'll do one by hand just so you can just remember how it's done. But normally, Excel, just all these softwares generate the pie graph for you or the bar graph. Now note, I know some people love to put crazy pictures and 3D images. Don't do that. Don't do that. Two-dimensional straight graphs, circular pie graph, no 3D, don't get fancy. Do not get fancy, because it can be misleading. The eye might not detect something properly. There's a couple of examples in the book. Now, one thing, and I forgot to mention this, all categories have to be placed. All categories must show up on the bar graph and on the pie chart. Do not leave any category behind. No category must be left behind. Now, of these two, I prefer the bar graph. It's just quickly visualize what's happening. I like bar graphs. Pie charts make me hungry. Of course they don't, but pie graphs, kind of difficult. Do bar graphs, make your life easier. Now, note, there are some things or some ways that people might want to try to deceive or trick you, or just people with good intentions who do not know how to properly do graphs or scale properly, which is kind of important. And by the way, when we're doing a bar graph, all the categories go in the horizontal axis, and the tally or the either the percentage or or the frequency goes on the left-hand side, and you have to label it percentage or total number of measurements, etc., etc. Now, one thing, some people sometimes might use little images, like a little car, or in the book, it's a very good example, like a computer. But then you say, okay, but on the car, I mean, is it the top part? Is it here? The computer, is it this corner? Is it the middle? Sometimes it's not properly, looks pretty funky, crazy proportions. Do not do that. Two-dimensional bar graphs. Keep it simple. Very useful, very efficient. That's what makes it nice. The second thing is scaling. You have to properly scale. Remember, you cannot just begin at a number, 50. Because let's say, for example, 60, and this is one of the examples in the book, 70, 80, 90, 100. Let's say, for example, one category is like this, and the other category is like this. If you were to just visually do a comparison, you would say, oh, well, this category is 1, 2, 3, 4, 5 times. So 5 times as many people like math versus, I don't know, I'm not going to throw another teacher under the bus. So there are 5 times as many people like math as they do, I don't know, Netflix, which is not real, pero bueno. Please let me enjoy myself. But if you actually expand the graph properly with the proper scale, going all the way down to 100, you will see that this graph is only actually twice this graph. Because a little less than twice, actually. Because this goes up to 60, this goes up to 100. So it's slightly less than half. Okay? So again, scale properly. If you're going to do this, remember there is something you can use to do that, and it's kind of like a little crunchy thing. Don't do that in bar graphs. Don't do that. It messes up the whole proportion, which is what makes bar graphs nice. So make sure you just use a proper scale. Do not begin at a non-zero value. Do not do the whole squishy thing. Just do a proper scaling. Make your life a lot easier. Okay, now we're going to continue with, one second, we're going to continue with marginal frequencies and two-way tables. Now, right now, bar graphs and pie charts are only measuring one variable and, like different categories within that one variable. For example, favorite ice cream, vanilla, chocolate chip, all those people don't know what they're saying. Pearls and cream, that's number one. Thank you, Ben and Jerry. Ben and Jerry's. Baskin Robbins. I'm crazy and I'm hungry. So again, pie graphs and bar graphs and pie charts only show you a single variable, all the categories within a single variable. Now we want to compare two categories or two variables, two categorical variables. We're going to use what are called two-way tables. And in the book, we see one that has on top environmental club. And pretty much we have a yes and a no. So this is one variable. Does a person belong to the environmental club? And that one variable has two categories, yes and no. On the left-hand side, we have another variable, snowmobile use. And here we have never, rent, owns, and that's pretty much it. And each one has its own numbers. So for example, never used, and let's just switch these so we have the exact values that are in the book. So we have no and yes. So I have 445, 497, 279, and we always total the columns and the rows. So when I add this column, I end up with 1,221. And here I have 212, 77, 16. When I add this column, I end up with 305. Now, besides adding the column, as I mentioned, we will also add the rows. So I have 657 here, 574, 295, and when I add this column, I will get this result, 1,526. Note, you could also add these two and end up with this value right here. I just like adding the columns because I know, I find it easier. Add the columns, add the columns, add the row, add the row, add the row, add the columns, and I'm done. That is a two-way table. Again, I'm seeing one variable belongs to environmental club, and the two categorical data sets are no and yes. And I have another variable, snowmobile use, and the categories within that variable are never, rents, and owns. So for example, a person could say, I do belong to the club and I own a snowmobile. So that person will fall right here. He belongs to the club and he owns a snowmobile. Now, when you look at these two-way tables, we're going to see that there are two ways we can analyze the data. For today, we're just going to focus on what's called marginal relative frequencies. Marginal. We're going to use the information in the margins, not in the cells. We're going to use the margin. And we use this to only compare a single category or to find the relative frequency of a single category within a single variable. For example, if I were to tell you, how many people belong to the environmental club? One variable, one category. I'm going to look at the total people who belong to the club, 305. And then I'm always going to divide it by the total amount of people. And that's going to give you your proportion or your percentage. Again, depending on the question, if I tell you what is the percentage of people surveyed belong to the club, you divide this and then you multiply by 100. Let's do another one. How many people rent snowmobiles? I look at the rent, the total at the margin, 574, divided by this will give you the proportion or the percentage. Again, marginal relative frequencies, we only use the informations on the margin and divide these values by your total. Again, marginal relative frequencies, a single variable, a single category compared to the total. And that's it for today.